Hey guys, let's take a look today at how to solve for variables in these parallel lines transversal problems. So for this first example that I'm going to do for you, we have this angle right here marked as 9x plus 2 degrees, and then this other one is 119 degrees. So since these are the two angles that are marked, the only two, those are the ones that we're going to have to use. So the first thing we need to do is determine what relationship they have to each other, so that we can determine if they are congruent or supplementary. So these two are on opposite sides of our transversal, and they're both on the inside of the two parallel lines. So these are alternate interior angles. We know that alternate interior angles are congruent, which means that I can go ahead and set these guys equal to each other. So we know that they have to have the same angle measure. So 9x plus 2 has to be equal to 119, and then we just have to solve. So if I subtract 2 from both sides, I get that 9x equals 117, and then divide both sides by 9, and I get that x is 13. And that's it. That's really all you have to do for these problems. Some of them get a little bit more involved, but really it's just knowing how to set it up. Let's look at a second example. So for this one, our two parallel lines are going to be vertical. And we've got this guy coming through here. So this is L and this is M. So L and M are our vertical lines. And then we have our transversal here. We're going to mark this angle as 8x minus 71 degrees. And then we're going to label this angle here as 5x plus 7 degrees. So those are my two angles. So that's this guy here and then this guy here. Those are on opposite sides of the transversal, and they are both on the outside of my parallel lines. So these are alternate exterior angles. We know that alternate exterior angles are congruent. So again, I can just set these equal to each other. So 5x plus 7 has to be equal to 8x minus 71. And then I just need to solve for x. So I'm gonna subtract my 5x over here to give me 3x. And then I'll add my 71 over, so that gives me 78. And then if I divide both sides by 3, x is gonna be equal to 26. Okay, I have one more example to show you. This is gonna be, let's see, for number 3. We've got our two parallel lines here. And in your notes, just try to do your best on these. We can just go ahead and mark these as being parallel with those two little markings there. And then we'll put the transversal here. And so we're going to mark this as 104 degrees. And then I'm going to mark this angle as 12x minus 8 degrees. And so for this one, we have the interior angle marked there, and then this is 104 degrees. So you can see that they're both underneath the transversal. They're on the same side of the transversal, and they're both on the inside. So that makes these consecutive interior angles. And we know consecutive interior angles are supplementary, meaning that they add up to 180 degrees. So when I set this problem up, I've got to take my first angle, which is 12x minus 8, add my second angle, 104, and set it equal to 180. So then I'm going to combine like terms. 12x plus, that should be 96, equals 180. I'll subtract 96, I get 12x equals 84. And so then x is 7. So if you haven't noticed yet, these are taken directly from the worksheet from yesterday. So I'm just going to go ahead and put that up here. So we just did 5, 6, and 7 off of the worksheet from yesterday. I just want to show you really quick that sometimes you have a problem like number 9 where there is an x and a y. So for this problem, you have to solve for your x value first by using the two that have x in them. And then you're going to want to go through, plug into one of them, and use the other set of angle pairs to solve for y. So sometimes there is a little bit of extra work. I'm going to write that one out for you really quick so that we can do that one together, just so that you can see how to do it, and then you can go and check your answers on that worksheet. So I'm going to write it as example number 4 here. So we've got our two parallel lines. And so we've got 9x plus 25 degrees here. We have 13x minus 19 degrees there. And then we have 17y plus 5 degrees here. So the first thing I want to do is use my two x value problems. These are corresponding angles. So for the first set, I know that corresponding angles are congruent. They're in the same position, so I can set them equal to each other. So 9x plus 25 equals 13x minus 19. If I subtract 9x over, then I'll get 4x on the right, and then I'll add 19 over, and that'll give me 44 here, which means that x is 11. So now that I know that, I can use one of these angles to figure out what my y value is. And so for this one, this 17y plus 5 doesn't have a set relationship with this top angle, but it does have a relationship with the 13x minus 9. Those are a linear pair, so that's what I'm going to use to solve for this. So to do that, I need to know what the angle measure of 13x minus 19 is, and now that I know x is 11, I can just go ahead and plug that in. So if I do 13 times 11 minus 19, that'll give me the angle measure there, which comes out to 124. So I know that these two angles added up together have to equal 180. So 17y plus 5 plus 124 equals 180. So that gives me, so my 17y is going to stay. If I go ahead and add these together, it's 129, and I know I have to subtract that from 180. So 129, or 180 minus 129 gives me 51. And then that gives me that y is 3. So just that's how you solve when you have two variables in the same problem. You're going to start with the two sections that have the same variable, solve that one, and then use one of those to solve for the other one.